Alright, now let's put together the last couple of concepts we've talked about with regards to the mole and the atom. We know two equivalences for the mole. One equivalence is that 1 mole of X, whatever it is you're talking about with X, is equal to 6.02 times 10 to the 23rd of those X's. That is the number of atoms that you have, that is the number of atoms that you have if you have 1 mole of that atom. The other equivalence that we talked about is that 1 mole of X is equal to the number of grams of X when you look at that atomic mass on the periodic table. The atomic mass is the number that is listed below the symbol. This is my atomic mass. It is a weighted average of all the different isotopes, and it is the number of grams that equals 1 mole of that type of atom. Another name for the atomic mass is the molar mass, because it is the number of grams, the mass that 1 mole equals. Each of these equivalences relates to the mole. So in this case I have actual number of atoms of X related to the mole. In this case I have the actual number of grams related to the mole. But what if we have the question, how much would 3.95 times 10 to the 30th atoms of lithium weigh? What if we're looking for the weight or the mass of a certain number of atoms? I don't have an equivalence up here between grams and numbers of atoms. I do have an equivalence between grams and moles, and I have an equivalence between numbers of atoms and moles, so this is going to take me 2 steps. It's still a unit conversion problem. It's still similar to the ones we've worked before, but I'm going to complete this in 2 steps. I'll start by setting it up exactly like we've set them up before. I'm going to start by putting question mark grams. You have to know that if you're looking for the weight, you're looking for the grams of lithium equals 3.95 times 10 to the 30th atoms of lithium. I don't actually have to write out the word atoms because the symbol Li stands for atoms of lithium. And then I need times in my ratio sign. I'm going to have lithium atoms on bottom. I'd like to put grams on top, but I can only do that if I have an equivalence here. These are lithium atoms. That's represented in my equivalences right here. And I can equate those to moles. So I'll put moles of lithium in the numerator. The 1 goes with the mole. Once I've got my units lined up, the 6.02 times 10 to the 23rd goes with the atoms. My lithium unit cancels. I'm left with moles. I'm not finished yet. I want to get grams, so I need another step. In this next step, I'll put the unit of moles of lithium on bottom so that it cancels. Units, units, units. And now my moles can be equated to grams. I'm trying to find grams, so ultimately I want that in the numerator. So there's my grams of lithium, and the numbers are 1 mole of lithium equals the number of grams that I find from the periodic table. I find lithium on the periodic table. It's 6.94 grams for every 1 mole. My moles of lithium cancels, and all that I have left is to plug it into my calculator. I'll plug in 3.95 exp30 divided by, because this is in the denominator, 6.02 exp23rd, times, because this is in the numerator, 6.94 equals, I have 3 sig figs here, 3 sig figs here, 3 sig figs here, so I will round my answer to 3 sig figs. It may or may not be expressed in scientific notation on my calculator. Mine's showing it without scientific notation, but I'm still going to round to 3 sig figs, so I'll end up with 455,000,000 grams of lithium. Now it's not wrong to express it this way, it's just a little awkward, so I might want to put it in scientific notation. where I'd write 4.55 times 10 to the 1, 2, 3, 4, 5, 6, 7. That's a 7. Grams of lithium. I might want to convert this to kilograms or megagrams because it's such a large number, but unless the question specifically wants that unit, I can just leave it in grams.